Okay, so this lecture is going to be on projectile motion and then also introducing the idea of horizontal projectiles. So first kind of thing to know about projectile motion is that this is going to be considered when an object is moving in both the x and the y direction. And is only under the influence of gravity. So it can't just be like an airplane that's moving in the sky in both the x and the y direction, because an airplane has its own engine. It has to be something that's strictly being thrown in the air, it's moving the x and y direction, and the only acceleration acting on it is gravity. So we only have ay, which is negative 9.8 meters per second squared, which we've already learned, and there is no horizontal acceleration. So that is what's considered a projectile. And there is a huge, big idea with projectile motion, and it's the key idea for this next kind of unit of study. And this key idea is that horizontal and vertical motion are completely independent of each other. One does not affect the other. Okay? So it's this idea that a vertical acceleration will not affect the x velocity. So vertical acceleration, specifically ay, will not affect horizontal velocity. And this is the biggest idea in this unit. It's fundamental, and when we get back into class, we're going to show a demonstration that shows this independence of motion, that even if something is moving horizontally, its vertical motion is not affected by its horizontal motion. Okay? So this allows us to then look at our equations a little bit separately in terms of when we're just looking at the x and we're just looking at the y, we can look at them independently and calculate them out, because one acceleration doesn't affect the other one's movement. Okay? And again, oh, I lost my cap. That's okay. There is no horizontal acceleration. Meaning we're going to be neglecting air resistance right now. Okay, so because there's no horizontal acceleration, the only quantity or the only direction that has acceleration is going to be the vertical direction. And that's going to affect our equations. So if we think about the equations that we've learned with motion, I'm going to show them to you right now. I do not want you to write these down. I want you just to kind of look and observe. Okay, so these are the equations that we've been studying for horizontal movement, for vertical movement. And they should look very familiar to you. The only thing that should look a little bit different is the fact that I've added some subscripts. So for v final x is equal to v initial x plus axt, delta x is equal to v initial xt plus 1 axt squared, and then v final x squared equals v initial x squared plus 2ax delta x. So again, I've just added subscripts. For vertical motion, again, these should look familiar. These are the motion equations that we looked at for free fall, where we had ay is equal to negative 9.8. Now the key thing to understand is that we just said that horizontally we have no acceleration. So the x acceleration is 0. And then for vertical, the y acceleration is negative 9.8. And we've seen that. Oh, I don't have enough room here. So I want to show you what happens to the equations because of the fact that the horizontal acceleration is 0. So if we look at the x equations, this one says that v final x equals v initial x plus axt. But if ax is equal to 0, this whole term here becomes 0. And if that whole term becomes 0, then that just goes away. And that just tells me that the final x velocity is equal to the initial x velocity. Well, if the object is not accelerating horizontally, it makes sense that the velocity shouldn't change. It should be equal. So this doesn't really tell us any information. So we're just going to get rid of that. This is why I told you not to write it. Okay, looking at the second equation, delta x is equal to the initial xt plus 1/2 axt squared. Again, if the acceleration is 0, this whole thing here is going to become 0. And if the whole thing is going to become 0, then we can just get rid of that term there. And we get this relationship that says that the displacement here is equal to the initial x velocity times time. And that should look like a familiar equation. This is just your distance equals rate times time. And then looking at the third equation that says v final x squared is equal to v initial x squared plus 2ax delta x. Again, acceleration for x is 0, so this whole term is going to be equal to 0. So that can just go away. And then that tells me that my final x velocity squared is equal to my initial x velocity squared. But again, if I have no x acceleration, my velocity is not changing, so this really doesn't tell me anything new. So the x equations really simplify for projectile motion. In fact, they simplify to just being one equation because of the fact that the horizontal acceleration is 0. We just have one equation that says that delta x is equal to v initial x times t. Oftentimes, this quantity is called the range. Okay? So that's your x equations. Your y equations, they don't change. They're still going to be the same y equations we've had for free fall motion, so they're going to still be there. So now if you want to write these down, this is the final equations that you're going to have for projectiles. You're going to have one equation for the x direction. You're going to have 3 equations for the y direction. And the thing to note is that time is the same for x and y. So the time value that you have in this equation is the exact same time value that you're going to have in these equations, okay? So it allows us to find time in one direction and use it in another direction. And that's going to be a problem-solving strategy we're going to see a lot, in that we will use either the vertical motion equations to find the time and then take that time and plug it into the horizontal motion equations, or vice versa. We'll use our horizontal motion equation to find time and plug it into the vertical motion equation to find something else. So that is projectiles in general. What we're going to do first is study a particular type of projectile called a horizontal projectile. And what distinguishes a horizontal projectile is this is when an object is released with only a horizontal velocity. Which means that there's an initial x velocity, but initial y velocity is going to be 0. And this obviously is going to be simpler because anything, if my initial y velocity is 0, then anything in an equation that has initial y velocity is just going to cancel out to become 0. So it's going to be a lot easier. We're still going to have the same idea that AY is going to be negative 9.8 meters per second squared. And my x, and in fact, again, my x acceleration is just going to be 0. But this in itself will simplify our equations. And we're going to see often that we usually use delta y to find time, and then use that time to find the range. So when you get back to class, we'll go over the structure, and then we'll start to do some examples of horizontal projectiles where your initial y velocity does cancel out and just becomes 0.